Hi friends, welcome to this video. So the question is KBR has NaCl type structure. What is the distance between K plus and Br minus in KBR? If the density is 2.75 gram per centimeter cube. Right. So they are told this KBR is the right potassium bromide. It is having the structure as that of sodium chloride. So what is the sodium chloride? We know that sodium chloride forms FCC, face centered cube, right? So face centered cube means, so if this is the cube, right? So the Cl minus, that Cl minus and Na plus will be there, right? The Cl minus forms FCC, whereas Na plus will occupy what? You will occupy octahedral voids. Will occupy octahedral voids, right? In the same way in KBR, so in the same way in KBR, K plus will occupy octahedral void, whereas Br minus will form what? It will form FCC lattice or structure. Alright. So we can find the distance. How to find that I will explain it later. So let us see. So they have given the density. What is density? Density is 2.75 gram per centimeter cube. Right. We know that in solid state density is nothing but what? Z, number of atoms per molecule, that is per unit cell, into molar mass m upon a cube into Avogadro's number, right? So we know density, right? We know Z. For FCC, Z will be how much? Z will be 4. Molecular weight of KBr we can find out, right? So potassium will be 39 and bromine is how much? Bromine is 80. So 80 plus 30, 39, that will be around 119, right? So that we know. Molecular weight we know, Z which is 4, that also we know. A naught Avogadro's number, what is that? 6.023 into 10 to the power 23, right? So this also we know. Density is known, so A cube I can calculate. So A cube is how much? A cube is nothing but Zm upon density into Avogadro's number. So if I substitute, so A cube, if I want to know A is nothing but Z, 4 into molecular weight is 119 upon density they have given 2.75, right? And Avogadro's number 6.022 or 023 into 10 to the power 23 whole raised to 1 by 3. So A I calculated. If you want to calculate, you can calculate and see. It will be around 6.6 into 10 to the power minus 8 centimeter. How it came into centimeter? Because this density is what? Gram per centimeter cube. So if I calculate the length, that is the A, I will get it in centimeter, right? So this is the applied question of solid state. Unless you know the basics, for you may feel this to be difficult, right? So as it is the JEE advanced question, right? So see, so A I found out. A is what? A is this edge length, right? Edge length we call it as A, that is to be 6.6 into 10 to the power minus 8 centimeter. So A is this much. So this is the A. But what they have asked the distance between K plus and Br minus, right? So we should know that. What we should know. So let me draw the structure so that you will understand carefully. So see, if this is the unit cell, right? So this is the unit cell whose length is A, and we know that KBr, right? So Br minus will form FCC, face centered. FCC means it will occupy corner and faces. So that will be around Z is equal to 4, right? You calculations you know, right? Total 8 corners, 8 into 1 by 8. Similarly plus faces, there will be 6 faces into 1 by 2. So overall we will get a Z to be 4 for FCC, right? So this is the 4. So here Br minus will occupy here, right? Here, every corner and the face. Whereas K plus occupies where? Octahedral voids. So those who are doing JEE and NEET, about this octahedral void they will teach in the class, right? So this octahedral void will be present in FCC. The octahedral void octahedral void will be present at center of corner and at center of unit cell. So with the red marker I can show that. See, so at the center the octahedral voids will be there, and at the corners of every edge length, corners of every corner. So right, so this is corner, sorry, at the center of every edge length, not the corner, that is edge length, edge length at center. See, so here will be there, here the octahedral voids will be there. So total octahedral voids will be again 4 octahedral voids will be there, because octahedral voids will be same as that of number of atoms, right? So so see, the K plus will occupy the edge center, right, as it is present in octahedral voids, whereas Br minus will be occupying the corners. So we know the distance A, so it will be what? A divided by 2. The distance between K plus and Br minus will be A divided by 2, right? So the distance between K plus and Br minus will be what? A by 2. So over A is what? A is nothing but 6.6 into 10 to the power minus 8 centimeter divided by 2. So it will be around what? 3.3 into 10 to the power minus 8 centimeter. So this is the correct option. So if you check the options, the option A is the correct option, right? So if you, unless you know the every basic concept of this solid state and the further application part of that, which leads to JE, right, which leads to JE, then only you can solve such problems, right? Thank you.